तर चालू करा.
Good afternoon, everyone. Today we are going to see about Internet of Things. What exactly we mean by when we say Internet of Things? What is it? And why everyone is talking suddenly about all these things? I am Dr. Hiren Dand. I am the coordinator of IT at Mulund College of Commerce, and I am involved at University of Mumbai, in various committees. So to start with, let me just show you the picture. I'm going to share. The Internet of Things. We are very much well aware about the Internet, and like we have our original community living, food, clothing, and shelter is part of our life, is a necessity of life. Nowadays, and of course, with this lockdown, we have seen that Internet is also very much part of our life. Nowadays, I'm communicating with so many of students sitting at various places anywhere in India, and that is just and only possible because of the internet. So internet became part of our life long back. We have heard about Internet of Humans. Over past few years, we are talking about Internet of Things. Why? What exactly do we mean by Internet of Things? As you can see in this slide, all these are things. There is no human. All these things can communicate with each other using the network, the internet. And that is why the word Internet of Things. The things are using internet. Originally it was meant for humans. Human beings use internet to communicate, to find information. And now, as years have gone by, we have Internet of Things. See, we have cars, we have buildings, we have mobiles, we have water taps, we have ambulances, buses, speakers, headphones, hospitals, fire extinguishers, aeroplanes, everything. All these are things, and things are able to communicate with each other, and that is what we call or we refer to as Internet of Things. What we refer to as Internet of Things. How it all started? You must have heard about driverless cars, isn't it? Lot of experimentations going on with driverless cars. Many years, Google has been working on that. Driverless cars. Tesla is working on
Hi, I'm
driverless
Ray Cowan.
cars. So I'm just going to share a small video about this driverless cars. Let us just have a look at the driverless cars.
And in this video, I'm going to show you how anyone can quickly and easily create doodle videos. Just
We have been doing driverless testing in Phoenix since 2017. We have done it at small scale with a few riders, but early fall we have really begun to slowly and responsibly ramp up this service. They can get matched with a fully driverless car where there is no trained driver in the car at all. We have been at this for over 10 years now on public roads driven for 10 million plus miles. We have done 10 billion miles of simulation, and the simulation is not only things that we have seen on the road, not only synthetic scenarios we have created, but also situations that we have made more adversarial than what we observe. For example, inserting cyclists and motorcyclists into a scene. And through a combination of multiple methods, we have reached the experience and confidence to be able to do this.
Hi, this is Seema with Waymo Rider Support. I just wanted to quickly welcome you to your driverless ride and let you know this ride will be free. If you have any questions or concerns, you can press the help button in front of you at any time to connect with Rider Support. Do you have any questions for me while I'm on the line?
No, I think I'm just sort of taking in the experience right now.
Okay, great. Well, I hope you have a great trip. And again, the help button is in front of you if you have any questions, okay?
Thank you so much.
However, we're constantly monitoring data both from the test driver cars, the simulation, as well as our driverless cars and our ongoing variety of testing. Anytime we find information that requires us to revisit a few assumptions, we will always put safety first and take the requisite actions. There are a couple of areas that we had to pay special attention to. For example, when law enforcement or first responders have to interact with a completely empty car. So that's an entire area that we designed and tested, but also collaborated with first responders in the local area. Tested, for example, whether or not we are able to detect all kinds of sirens and flashing lights, but also how a police officer in an emergency can take over the car if they need to.
It was a little bit more of like sort of a classic design problem when we had all of this information and we had to create a hierarchy of that information. So what's most important, and then how does color map to what's most important? And so when we see like nearby pedestrians or cyclists, those are rendered as white sort of laser points on a dark background because the contrast there is the highest and they stand out the most. There were some practical considerations as well. We really want to go for a lean back experience when you're in the car. So we want to make sure that that UI isn't in your face and distracting. And so that's why there's a dark color scheme to it and the colors are a bit subdued. It's taken years really to sort of understand the vast number of scenarios out there where people have different information needs. So I might be going to work in the morning, there's no construction, I'm coming home, there now is a construction site that's popped up, and does the car understand that? Again, we're trying to reinforce the car does understand those changing road conditions. And we've been pleasantly surprised. It's one of the examples, unprompted in our user research, that people often cite. The fact that like, hey, there are 14 traffic cones on the side of the road here, and I can see those in the passenger interface, and they're very impressed that the, again, to that level of detail around what the car is picking up.
Cool.
These are all in one piece. Check your
Yeah.
surroundings before exiting.
Thank God.
And remember to
All that learning we want to build into the product as we are learning them, refine our flows, refine our passenger screens, refine our rider support, but also in terms of how the product experiences. For example, any feedback they may have about how the routing is, their preferences on which side of street they would like to be dropped off on, if they want to be dropped off right in front of Walmart or slightly off it where folks aren't just exiting with all of their stuff from Walmart. So on a variety of these, I think there's product refinements we continue to do, and we're in a unique position to do that because we're not just asking users what they want, we're actually seeing them in the fabric of their daily lives. We are responsibly and thoughtfully ramping this up. So right now that ramp up has already begun. And as we are able to incorporate all of this feedback, I see it as the natural progression that more and more of the rides will be on completely driverless cars.
Yes. So this is how the future, in fact, we can say the present is being. It will soon being released, the driverless car. No one is going to drive, it is just going to be without driver. So number of seats will also increase. If 5 people are there, there can be 5 passengers because the driver is absent. And that is the future. And not very distant, very new, very near. So today we will be learning about what is Internet of Things, how the IoT works, the current status and the future prospect of IoT, knowledge management from data to wisdom, the future of IoT, the potential of IoT, few applications of IoT, the technological challenges of IoT, criticisms and controversies of IoT, and some references which we have used. To exactly define Internet of Things, it is a network of physical objects or things embedded with electronics, software, sensors, and network connectivity, which enables these objects to collect and exchange data. The things talking to each other through network. And of course, when you only started, you have known the equation of IoT. There are sensors, actuators, controllers, sensors, and actuators. So physical thing plus control sensor actuator plus internet is Internet of Things. And this is the basic definition of Internet of Things. The objects communicate to exchange data. IoT allows objects to be sensed and controlled remotely across existing network infrastructure, creating opportunities for more direct integration between the physical world and computer-based systems, resulting in improved efficiency and accuracy and economic benefit. A lot of, like, can you imagine now? Of course, when we say that drivers will lose the job, yes. For a country like India where we have majority, it is hugely populated, yes. But in many countries, the population is not that much. And then what will happen? The number of skilled laborers will increase a lot because with technology. Not that people lose job, they need to upgrade themselves for the technology. If they don't do it, they're out. To survive, they will need to learn new things. And this is how the world is going to be, with a lot of automation. Smart homes, smart cities, everything is in place. There are so many people who have smart homes. How it works? It is all based on the Internet of Things, where objects communicate with each other. Imagine, we are having a house, we have a refrigerator. The refrigerator is an IoT refrigerator. The moment it senses that the level of milk has gone down, it informs the dairy to supply the milk. Everything is automated. Everything is tracked upon. Whatever we are doing, wherever we go, we are tracked. So, suppose we are returning home and we know, okay, our mommy is there, she will keep tea, coffee, milk ready for us as we are home because we are hungry. That is possible. Because we are being tracked. Exactly when you reach, the things are ready for you. All this happens because of the Internet of Things. Now, when you talk about Internet of Things, it is, it involves a lot of things. There is hardware, and of course there is software, and there is artificial intelligence also built in that. Because when you talk about driverless cars, you can imagine how much of intelligence would be built in that car, so that it does not crash, it does not hit anyone. So things in all these disciplines have become combined with each other. Things in the IoT sense can refer to a wide variety of devices, such as, in medical field, heart monitoring implants. We implant a small chip in our body which will monitor our heart. Biochip transponders on farm animals, electric dams in coastal waters, automobiles with built-in sensors, DNA analysis device for environmental food pathogen monitoring, or field operation devices that assist firefighters in search and rescue operations. These devices collect useful data with the help of various existing technologies and autonomously flow data between other devices. I'm sure all of you must have learned the first chapter of IoT, where there are a lot of simple examples, like a blinking light in an umbrella. Umbrella is a daily use device. And of course, the book being written by UK people, where it rains unpredictably any time, any day around the year. So the umbrella has sensed the weather and sees that it is going to rain, and also sees that we are moving out of the house. It starts blinking, that pick me up, it is going to rain. That is the power of IoT. History of IoT. The concept of IoT first became popular in 1999 through Auto ID Center at MIT and related market analysis publications. Radio frequency identification was seen as prerequisite for the IoT at that point. If all objects and people in daily life were equipped with identifiers, computers would manage and inventory them. Besides, using RFID, the tagging of things became may be achieved through such technologies as near field communication. Nowadays, all our credit cards and all, they have NFC chips embedded. So we just take it near it and it works. Barcodes, QR codes, Bluetooth, digital watermarking. A lot of technologies are there which have helped IoT develop so much. How does IoT work? Internet of Things is not the result of single novel technology. Instead, several complementary technical developments provide capabilities that help to bridge, that have been taken together to help bridge the gap between the virtual and the physical world. The capabilities include communication and cooperation. The devices should be able to communicate and should understand each other. Addressability. Every device, when we say, should have some address, and when we talk about internet, the type of address that is needed is the IP address. Identification. So with the help of IP address, we can identify. Sensors are involved, it needs to sense for what it is being used. So sensing. Actuators, the physical movement of that is controlled by actuators. Embedded information processing. Everything is embedded and processing is done on that. Localization. For every native, he needs a local language. So that is also possible. And user interfaces. There may be user interface. For example, we have a button which is, like a rotary knob. So we know that it has to be rotated. We cannot expect that a rotary button be pushed, behave like a push button. No. So things should be obvious. It should not be that people need to learn in some way or the other. Obvious things should be obvious. We know nowadays, everywhere, the play button, the pause button, the stop button, all nowadays have been standardized. By looking at the device, we should be able to understand. We don't need to have, explanation for easy things. If that also starts building up, then that is not a good design. How does the IoT work? So in simple words, we have, RFID sensors, smart technologies and nanotechnology to identify and track the data of things. To collect and process the data to detect the changes in the physical status of the things. To enhance the power of the network by devolving processing capabilities to different part of the network. And finally, to make the smaller and the smaller things have the ability to connect and interact, however small the thing may be. We want everything to be connected. So that is what is Internet of Things. The structure of IoT. The IoT can be viewed as a agentic network consisting of network of devices and computers connected through a series of intermediate technologies, where numerous technologies like RFIDs, wireless connections may act as enablers of this connectivity. These are very small. When we are talking about driverless cars, the amount of sensors, you can imagine how many sensors will be there, what all things are detected, huge thing. These are just to begin with, but on the whole, we may have very big things connected to each other. Originally, it started with RFIDs. Many of the shops, they started using RFID. What was the reason for introducing the RFID? It was introduced by Gillette blades. Now what used to happen, Gillette blades are very small. In superstores, it is very easy to put the blade in your pocket and walk away. Of course, in Mumbai now, see, they generally keep it locked. So if you want, you go there, ask them, and they will open the lock and they will give. But originally, Gillette in foreign countries everywhere, Gillette blades were stolen a lot. They used started suffering losses. They used to wonder when the demand is so high, why are we losing the income? Why we are at loss? So why we are at loss? So that we need to. Gillette was planning that okay, let us introduce something. So they placed RFIDs on their blades, and of course RFID receivers were at the entrances. So anyone walking out, beep would come. So then they incurred a cost of RFID, but the loss came down. They entered into the profit back. So RFIDs were there for quite long. Feeling things. Sensors act as primary devices to collect data from the environment. All type of sensors are available. We have temperature sensors, thermometers, we already know that. Moisture sensor, humidity sensor, fire sensor, all type of sensors. And the amount of data, can you imagine, is generated is too high. Every sensor produces so much of data. Shrinking things, miniaturization and nanotechnology has provoked the ability of smaller things to interact and connect within the things or smart devices. You know, things have become smaller and smaller and smaller and still capable of doing powerful things. Because of nanotechnology, you know, for so many years, the speed of microprocessor has gone on increasing, but the size has remained same. The number of transistors which are embedded on microprocessor has grown to a very large number, but the size has remained same, miniature. What is the size of a CPU? It is just 3.5 centimeter by 3.5 centimeter. Thinking things, embedded intelligence in devices through sensors has formed the network connection to the internet. It can make the things realizing and the intelligent control. So what we saw, you know, the Waymo car, you can imagine how much of intelligence is built into it. Tesla is also experimenting with their own Tesla cars. See the current status of IoT. More connected devices than people. 6.5 devices, 6.58 per person. 50 million connected devices. And 7.6 billion is the population of the world. See the graph, how it is proceeded. 2020 we are at present 6.58 devices per person, roughly 50 billion connected devices. World population 7.6 billion and number of devices 50 billion. Huge number. All the devices are getting connected to each other. IoT as a network of networks. That is also there. Meshing of networks we call. Individual networks are there which are connected together with security analytics and management. Knowledge management, turning data into wisdom. That is what is going on in the world. We want to create everything so that we can just relax and the machines will work and nothing bad about it. But to do that, lot of things are needed. The very important thing is data. We process the data and convert into information. All the information we give it to the machine to gain the knowledge, understand the data, and lastly, wisdom, evaluate understanding. The more data that is created, the better understanding and the wisdom people can obtain. That is why those of you who must have heard about AI, there are self-learning algorithms. So from data, we convert data to information, we gain the knowledge, we gain the understanding, and finally, wisdom. What happens when 50 billion machines become connected? Industrial internet, connected devices, real-time network planning, shipping visibility, brilliant hospital optimization we have, intelligent medical devices we have, connected machines, smart grids, logistics optimization, and factory optimization. The sky is not the limit. It's only beginning with IoT. The potential of IoT. The value of industrial internet is huge. Connected machines and data could eliminate up to 1.5 billion waste across industries. Aviation industry, power industry, healthcare, rail, oil and gas. Every industry contributes and see estimated value over 15 years in US dollars. Types of saving: 1% in fuel savings, system of inefficiency because of connected devices. Next. Unlock the massive potential of IoT. The potential lies in improved performance, reduced cost, creative, innovative services, and finally, new revenue stream. Every one of us here looks for new revenue. That is human psychology. We want to see how we can get more money. So we can do that. And that is possible. With new avenues opening up, new revenue streams are being developed. Technology roadmap of IoT, how everything got evolved. As we know, with RFID tags, RFID tags for facilitating uh, routing, inventorying, and loss prevention. Above that, we have surveillance, security, healthcare, transport, food safety, and document management. We have supply chain helpers, vertical market applications, ubiquitous positioning, and physical World Wide Web. Miniaturization, as we spoke already, smaller and smaller things are becoming. Locating people and everyday objects. I'm sure all of you must be remembering the where dial. The author talks about the where dial in the first chapter. What is where dial? It indicates where the person is. The evolution of things. Applications of IoT. The ultimate goal of IoT is to automate human life. Everything will be automated. Applications, building and home automation. Nowadays we have seen that air conditioners, they come, when no person is there in the room, they go into sleep mode. When anyone enters, they go into fast mode automatically. No remote required, just you enter and go. It puts off. As you enter, it starts automatic. IoT widely used in manufacturing, medical and healthcare systems. Yes, we just saw implanting chips into body. Media, medical, of course, we saw a lot of applications. Entire media has a lot of IoT things. Environmental monitoring, very, very important. We have tortured the environment like anything. So now we need to monitor and maintain. Infrastructure management, yes. Energy management for transportation, and finally the better quality of life for elderly. You can see that people have started using social media at whatever age we may say. So people have to get used to it. You cannot say that now my time is over and अभी क्या मेरे को एक साल निकालना है, TY हो जाएगा. No. Whenever we will accept a TY, let us finish it with whatever we have to learn. Diverse applications. Home consumer, light bulbs, security, pet feeding, irrigation controller, smoke alarm, refrigerator, infotainment, washer, dryer, energy monitoring. All these things can be automated. Transport mobility, traffic routing, telematics, package monitoring, smart parking, insurance adjustments, supply chain, shipping, public transport, airlines and trains. Patient care, widely used IoT, we saw already. Building infrastructure. HVAC, what is HVAC? It is heating, ventilation and air conditioning. When too much amount of data is generated, we need to take help of cloud. On cloud, different services are available. So for cloud, at any data center, HVAC is a crucial thing. Once set, there is No issue generally. HVAC. Cities, industries, electrical distribution, maintenance, surveillance, storage. Smart grid emergency services, waste management. That is the company. Smart parking. See the way the cars are parked. Residents can identify and reserve the closest available space. Traffic wardens can specify non-compliant usage, and municipalities can introduce demand-based pricing. They know that now, okay, today a lot of traffic is going to be there. People would like to park. They may increase the price. Then, of course, decisions are there at higher level, but still. See the way four cars are parked in a single dead block slot. Efficient waste management systems in smart cities supported by sensing as a service. Sensing as a service model. Garbage bags are there. They also are automated many places. Efficient waste management in smart cities supported by sensing as a service. Why I'm pausing, so that you can have a look at the diagram. Otherwise, if I keep on talking, you will not listen to me. So I took pause so that you can just see the diagram first. Now, since you are comfortable with the diagram, I'll start talking. Infrastructure with access to energy sources and long range data communication. As of now, we cannot work without the internet because everything is going on the internet. But how that takes place in companies? Long range data communication. So it senses. Cloud platform that supports sensing as a service. And it may go to city council, recycling plant, manufacturing plant, or health and safety authorities, depending on what type of information it is. See everything. Sensors, even in the holy cow. The cattle is fitted with sensors so that the farmers can monitor their cows' health, track their movements, ensuring a healthier, more plentiful supply of milk for people to consume. On an average, each cow generates about 200 MB of information per year. Of course, we know nothing remains static, especially when it comes to the internet. Initiatives and advances such as Cisco's planetary skin, GE's industrial internet, HV's central nervous system for Earth, and smart dust have potential to add millions, even billions of sensors to the internet. As cows, water pipes, people, and even shoes, trees, and animals become connected to IoT. The world has the potential to become a better place. Why we are doing all these things? So that the world becomes a better place to live into. With trillion sensors embedded in environment, all connected by computing system software and services, it will be possible to hear the heartbeat of Earth impacting human interaction with the globe as profoundly as Internet has revolutionized communication. All the companies are working towards such type of automation, AI. Everyone is working towards it. How much more IoT can do is left only to our imagination. See, online exams have started. This year, the proctoring has kept but to minimum. Soon, maybe if you have to appear for online exam, you will have to have internet. The device will proctor. And presently also a lot of AI-based software are there. The moment you move out of the screen, the moment two faces appear, it reports. Everything is possible. You may embed a chip in your body, and during the exam you will write from the chip all the memory that it gives you. So things are changing at faster pace, and whatever you imagine will be available tomorrow. So whenever some new thing comes, it is like a magic, but then it settles down. Any new innovation, initially it is like a magic, and then over time it settles down. For example, everyone has a smartphone these days. Few years ago, everyone did not have. And there used to be a landline, and you cannot walk while talking. So this generation has seen everything. And what was left was Corona, so that from 6 months people are sitting at home. But it has a lot of advantages also. See, this lecture is online. Had I to come physically to a place to deliver lecture, then a lot of time is involved, a lot of things, constraints, and of course traveling time is involved. Here I can give lecture sitting right at home. I don't need to travel anywhere. It has changed the entire way things are working. And whatever will happen further is just whatever you imagine. That is why I also say that when you build a project, now let it be small project, but build something which is useful to someone. Otherwise, if you're not interested, you build websites which are useless, you build apps which are never opening again after exams. Not good, not good. Let us develop something. We should think about entrepreneurship. So like that we need to think and put the things in place. You decide your own. How all these things started? Uber, small group of entrepreneurs, they had that idea, let us start something which is different. Everyone can think different, and with IoT, imagination is the limitation. Only whatever you can imagine, you can implement. So think something out of the box, be it small. As small as we saw that blinking LED on the umbrella. Yes, it is possible. Most of the places nowadays have good network connectivity, though there are few places where network connectivity has issues. But otherwise, the entire world is connected with the Internet of Things devices. So, think and develop good projects. And IoT is very interesting. With this course like B.Sc IT, it is not that only you have to become programmer. We have seen networking, we have seen electronics, testing, lot of options are there. Database. And this IoT is unlimited. Whatever you want, you build a small device, start marketing it, nothing like that. You are the director, the CEO of your own company. So, imagination. And Believe me, everyone can imagine something, and you have to put, not just imagine, you have to put into place. And that is where you need to be enthusiastic about what you are doing. Internet of Things is the next stage of the information revolution and referenced the internet connectivity of everything from urban transport to medical devices to household appliances. Integration with the internet implies that devices will use IP address as unique identifier. IPv4 was there, it became extinct. But IPv6 is very large, 2 raised to 32. IPv6, 4.3 billion. So you can imagine IPv6, IPv4, 32 bits. IPv6, 128 bits. So huge address. Objects in IoT will not only be devices with sensory capabilities, but also provide actuation capabilities, example bulbs or locks, controlled over the internet. You know, suppose we are not at home, we want to rent a house in Goa. All the keys and everything are with you. So you need not go to open the door. Everything will be connected via internet. You remotely, and you can open from anywhere in the world. You can open your parking garage, you can open the door. Everything can be done. And that is what the smart home is. So here this is an example, bulb control, lock control over the internet. On the other hand, IoT systems should also be responsible for performing actions, not just sensing the things. Intelligent shopping systems, for example, could monitor specific users' purchasing habits. That is what internet is all about. You search for some item in Google, you go to your Facebook, you will see same ads. That okay. Everywhere we are being monitored. So whatever we search, immediately it is available as an ad to us. These users could then be provided with special offers on their favorite products, or even location of items that they need, which in their fridge is automatically conveyed to the phone. So even vegetable vendor we can connect directly. So it will tell vegetable vendor, the items are over, please go and supply. Additional examples of sensing and actuating are reflected in applications that deal with heat, electricity, and energy management, as well as crews assisting transportation systems. Other applications that the Internet of Things can provide is enabling extended home security features and home automation. Everything, you know, if burglars enter, we can report the local police. That is what happens in Western countries, developed countries. Wherever something happens, police reaches there immediately. Shopping scenario with IoT. When entering the doors, scanners will identify the tags on the clothing. When shopping in the market, the goods will introduce themselves. When moving the goods, the reader will tell the staff to put a new one. When paying for goods, the microchip of the credit card will communicate with the checkout reader. So everything is automated. See the amount of automation that is going on. We have seen nowadays, we have, this Fitbits. What is that? That is again an IoT device. How many steps have you walked today? How well do I sleep? It observes sleeping patterns. See, the Fitbit Flex. Over past 30 days, how much time you have been awake? All things are sensed. Small device with few sensors. Now with Corona coming in, you can have a device which will sense the temperature automatically. All the statistics are captured. I want to know more about myself, for us itself, because we don't write to write everything or what we are doing everything. So we can write like this: where you're going, who you have interacted with, how long you have spoken to your friends, the affinity of connections, how long it takes to get to the work, the tone of messages, the way we talk, it will recognize. And it will change also if you want. The amount you text, tweet or update, how much exercise you are getting, how much you get distracted. All these things can be understood using IoT. Thought controlled computing, that is left now. Your thoughts are captured. Thoughts are captured. The flagship product, Mindwave, is a headset that can log into your computer using just your thoughts. Researchers recently used EEG headset to develop a toy car that can be driven forward with thought. You think and the car drives. Neurosky's smart sensors can also track your heart rate and other bodily metrics and can be embedded in the next generation of wearable devices. The tagline is, we make it possible for millions of consumers to capture and quantify critical health and wellness data. SoftBank funder. Technological challenges of IoT. At present, IoT is faced with many challenges such as scalability. It cannot scale easily. It cannot expand. So it is a challenge. There is no standardization. People may write their own protocols, which is not a first-class citizen of Internet. People who use existing protocols, slight modification can be done if required. Interoperability. All the devices should be interoperable with one another. Devices should be able to discover themselves or discover the network. Software would become complex. The data volumes are increasing by leaps and bounds. Power supplies, interaction and short-range communication, wireless communication and fault tolerance. All these things we need to build. And these are the challenges which we have to overcome. Big data is not magic. It doesn't matter how much data you have if you can't make sense of it? So we need to make sense out of that data. We need to make sense out of that data. So big data. We talk big about data, big data. And whatever data we have to make sense out of it. Otherwise, it's of no use. Criticisms and controversies of IoT. Scholars and social observers and pessimists have doubts about the promises of the ubiquitous computing revolution and the areas. What is ubiquitous? You know, these computing terms, I'm sure you have heard in these chapters. Ubiquitous is anytime, anywhere, on any device. Another word is calm and ambient technology. Calm and ambient. What is calm? It works in background. Whenever required, we can bring it in front. But it keeps on doing its work calmly. The computing revolution has happened. So we have, this privacy, security, autonomy and control, social control, political manipulation, design, environmental impact, and human moral decision making. IoT is going to help in everything. Yes. So summarizing, what we are seeing, Internet of Things is only the tip of an iceberg. See this, what is below. We are only having the tip of an iceberg. And below, we have huge amount of things which are yet to come and which will certainly come. And each one of you will be contributed to that. Remember that. All of us will contribute something new, something different, because we have imaginating power. Humans can think, we can imagine. And why do we do that? Because we want to make our life easier. And IoT is what is helping us to make our life easier. IoT is what is going to make our life much easier. So we are only at the tip of an iceberg, and we are going to have a lot of things coming up. Okay. So this is about the introduction and overview of the Internet of Things. Of course, you use these things as references.
Sir, thank you.
I would like to thank Dalvi College, Pindarkar College, and everyone to invite me for